So this recording is going to give you a little bit of idea as to the answers and kind of a little bit of guidance on how to handle constant acceleration graphs. So this will be a little quick summary of what you should have been working on as part of your readings and as part of this worksheet where you already have made your predictions and have gone through each of these slides. So this is just the final check to make sure you understand some of those ideas and concepts. So to start with constant velocity, we say constant velocity on a position versus time graph is like our buggy. So when you talk about constant velocity, you're talking about a relationship between position and time that's linear. It could have positive slopes, could have negative slopes, could have negative or positive y-intercepts, but it's all about the line, so a linear relationship. Now, if we know that we're talking about constant velocity, the velocity staying the same, well, then we know that we want our velocity versus time graph to be horizontal. In other words, it stays the same throughout the time period we're looking at. It's like it's on cruise control. If you're talking about being in the top quadrant, the first quadrant, it's telling you that you have a positive velocity, which represents a positive direction. Or if you're in the fourth quadrant, it's showing you that you have a negative velocity or a negative direction for your graph and for your motion. But whenever you talk about constant, it means it's going to have a horizontal line for VT. Oh, it also asks you, can you tell the direction? Well, as we said before just now, your negative direction and positive direction. So in other words, if you're in the first quadrant, it's showing positive direction. If you're in the fourth quadrant of a velocity versus time graph, that's negative. Whereas on the position versus time graph, your slope tells you direction. So if it's a positive slope, you know you're moving in the positive direction. If you have a negative slope, it means you're moving in the negative direction. Now, as you're going down and you look at the part involving your graphs, if you want to have then a graph that has a faster constant velocity, well, we know our slope of our position versus time graph shows us our velocity value. So slope of our position versus time is equal to our average velocity. So as the slope gets steeper, it means we're going faster. Now, for our velocity versus time graph, if we know we're getting faster, then we know we're going to be having a larger velocity value. So that would mean that your velocity versus time graph would just have a horizontal line that is further from the x-axis, so a larger value. So in this case, 3 meters per second as opposed to the original 2 meters per second. So if we're going from slow to fast, so if we're looking at a position versus time graph, when we know we're moving in a slow direction, so slow direction, in this case I'm going to show positive direction. Slow would mean a shallow slope. And then at 5 seconds it gets steeper, so it's going to look something like that. And what you'll see is that as we start to look at these graphs, we'll eventually have this increase in speed be constantly increasing. So slowly or kind of at a slow rate getting faster and faster and faster instead of this quick abrupt change at 5 seconds. And as we do that, you'll see that you start to get a curvy appearance. It starts to get curvy as you see that your slope goes from shallow to getting more vertical to getting more vertical. In other words, more vertical or more steep, more vertical, more steep for your slope means it's getting faster. So on your VT graph, if you start with a small or shallow, like a small velocity in that positive direction, and then you go to a bigger velocity, it would normally look like this if you're going from really slow to really fast with an abrupt change. But on your graph, if you start to do this and have this increase in speed be a little bit more progressive, and as that happens, you'll see that it's going to start to look like a line. You're going from slow velocity values to fast velocity values. So in other words, you go from slow to increasing speed, linear. Now, if we do reverse, now we're going in the opposite direction, negative direction. It would mean that my graph originally starts for my position versus time with a shallow slope in the negative direction. So negative direction, shallow slope, and then a steeper, larger, more negative slope as it gets faster after 5 seconds. So once again, if you have this become a more progressively increasing speed, this would become curvy, it'd be quadratic. As a result, this would show an object that's getting faster in the negative direction. Now on the VT graph, if we start slow in the negative direction, you have a small negative value. And then at 5 seconds, it gets to be a larger negative value, something like -4 meters per second. And if you once again show this is getting increasing at a constant rate, if it's increasing at a constant rate, it will go from slow to fast in more of a linear direction. So once again, this is a negative direction getting faster and faster. As we've talked about in the past, when we talk about velocity versus time graphs, first quadrant is where we have our positive velocity, positive direction then. Fourth quadrant shows us negative velocity. In other words, things that are moving in the negative direction would have a velocity in the negative direction, and therefore those graphs would be showing up in the fourth quadrant. And besides just showing direction, we can also tell if things are getting faster or slower. And I always will go through and label my graphs as fast, slow, slow, fast. So if you look at fast to slow and slow to fast, you can tell that things are moving and changing speed if my line goes from a slow value, and as time goes along, it gets to a faster region. Or the reverse can be true. If I'm looking at something that's moving in the positive direction, it starts out fast, maybe at 6 meters per second, and it goes down to 2 meters per second. You can see that you go from fast values to slow values. If you're looking at something that involves the negative direction and you go from slow, so the slower part, and it moves to the faster part, it would look something like this. As time goes along, as you go from 0 seconds to 1 to 2 to 3 to 4 to 5 seconds, you can see that your velocity has now gotten more negative. It's gone from slow values to fast values. So in other words, that line is going from a slow region to a fast region in the negative direction. And if we reverse that piece too and we go from fast to slow, it just means we go from big negative values to smaller negative values. Now, this might make a little bit more sense as we start to look at some more other pieces, but just kind of summarizing this idea, if we're going from slow regions to fast regions in the positive direction, it would look like this red line. We know it's in the positive direction because it's in the first quadrant, so positive velocity. And you can see that the line starts negative and then gets to be, starts slow, my bad, starts with slow or small velocity values and then starts to get into larger, bigger, faster velocity values. If you're going from fast to slow, now you've reversed. You've gone from big meter per second values to smaller meter per second values, and all in that first quadrant, positive velocity. Next one down, if you're looking at this, you can go from slow to fast, and this is going to be in the negative direction. So slow values to fast values, but because of the fact that it's in the negative direction, we know it's all going to be in the fourth quadrant. If you're going from fast to slow in the negative direction, you're going from fast values to slow values. So in other words, you're getting closer to the x-axis as you go from fast values to slow values. And it's in the negative or fourth quadrant. And just a little kind of touch on what this means when it comes to slope. So if you're looking at this velocity versus time graph, and we know that things have physical significance, and we know that things are going from, in this graph, from slow to fast. So we want to figure out what's the meaning of the slope of that line. Okay, so we know it's going from slow to fast, so it's speeding up. And if we look at the rise piece, we know it's rising by changing its velocity. So when we talk about our slope, we're looking at our rise as being our change in v, change in velocity. Our run then is the change in our horizontal axis, which is going to be our change in time. In other words, my slope tells me how is my velocity changing over time. And in this case, we can see that the velocity is changing by getting faster for this example. And when we talk about things getting faster or getting slower, we call that acceleration. So my slope of change in velocity over change in time tells me my acceleration. Now, as we know, when we have slopes that are positive, like this example over here, the positive slope shows that I have a positive acceleration. If I have a negative slope, like that purple line, this negative slope would tell me then that I have a negative acceleration. So looking at this graph as we're kind of summarizing all this, you can see up in the upper left-hand corner, we have a graph that's going from slow values to fast values. So in other words, it's speeding up. It's in the first quadrant, so it's going to be positive, and it has a positive slope, so it's a positive acceleration. Next line over. We know it's going from, and remember this is the fast, slow, slow, fast. It's going from slow values to fast values, so it's speeding up. It's in the fourth quadrant of my velocity versus time graph, so it's negative, so moving in the negative direction. And it has a negative slope, so a negative acceleration. As we continue on down into the lower right-hand corner, continuing clockwise, we can see on here that we have a graph that is going from fast to slow. So it's slowing down. So going from fast to slow. And it's in the first quadrant, which means it's moving in the positive direction with a negative slope. So it has a negative acceleration. Continue on down to the lower left-hand corner. It's going, so remember, fast, slow, slow, fast. It's going from fast values to slow values. So it's going from a big velocity to a small velocity, so it's slowing down. It's in the fourth quadrant, so it has a negative direction. And it has a positive slope, so a positive acceleration. Now, you can pause and take a look at these graphs. Remember, again, we're just slowly kind of just starting to touch on all these graphs and their meaning. So just use this as an opportunity to check your understanding based on what you see going on. So pause and take a look at your values and make sure your slope values and your kind of interpretation of the graph is the same as what I have on here. Lastly, we have this graph over here. This is for 7 through 12. Check your graphs. Make sure that they're the same as yours. And once again, I want to remind you, whenever you look at your graph, you first want to look at what kind of graph is this? What kind of graph is this? Is it a VT graph or is it an XT, position versus time graph? Because you can tell that the graphs are going to look different based on that. Check your graphs. And lastly, what I'd like you to do is make sure you finish up the rest of these graphs as homework for tomorrow and for our next class so we can make sure everyone's on the same page with these graphs. Once again, we're just scratching the surface on these graphs, so use this as an opportunity to check your understanding. Let me know if you have any questions as you go along. Otherwise, hopefully this worked well and hopefully you were able to get your lab practical done too. Have a great day.